a rollup or like a state machine that's running inside a trusted execution environment. And over time, we decentralize this and make it permissionless. The idea is the TEEs provide real-time proving, and the rollup itself provides programmability. It would be very cool to have a rollup that would settle instantly back on the L1, such that we could have this fast and cheap execution environment that is for L1 assets. With the TE, the proving is instant because, obviously it's a different trust assumption, right? However, as we're running the runtime inside the trusted execution environment, we can create an attestation from the TE and prove to whatever platform that we want, this is the execution that took place instantly. When you enhance this proving capability with actual programmability, you unlock a lot of cool use cases and applications that just pure proving does not give you. And this way you can, go towards being more of a hub rather than just like a proving network, if that makes sense.
Welcome to Epicenter, the show which talks about the technologies, projects, and people driving decentralization and the blockchain revolution. I'm Friederike Ernst, and today I'm speaking with Can Kisagun, who is the CEO and co-founder of T1, a real-time proving rollup that tries to eliminate fragmentation in Ethereum. Before the interview, I'd like to tell you about our sponsors this week. If you're looking to stake your crypto with confidence, look no further than Chorus One. More than 150,000 delegators, including institutions like BitGo, Pantera Capital, and Ledger, trust Chorus One with their assets. They support over 50 blockchains and are leaders in governance on networks like Cosmos, ensuring your stake is responsibly managed. Thanks to their advanced MEV research, you can also enjoy the highest staking rewards. You can stake directly from your preferred wallet, set up a white label node, restake your assets on EigenLayer or Symbiotic, or use their SDK for multi-chain staking in your app. Learn more at chorus.one and start staking today.
This episode is proudly brought to you by Gnosis, a collective dedicated to advancing a decentralized future. Gnosis leads innovation with Circles, Gnosis Pay, and Metri, reshaping open banking and money. With Hashi and Gnosis VPN, they're building a more resilient, privacy-focused internet. If you're looking for an L1 to launch your project, Gnosis Chain offers the same development environment as Ethereum with lower transaction fees. It's supported by over 200,000 validators, making Gnosis Chain a reliable and credibly neutral foundation for your applications. Gnosis DAO drives Gnosis governance, where every voice matters. Join the Gnosis community in the Gnosis DAO forum today. Deploy on the EVM-compatible Gnosis chain or secure the network with just one GNO and affordable hardware. Start your decentralization journey today at gnosis.io.
Welcome to the podcast, John. It's a pleasure to have you.
Hi, Friederike. It's a pleasure to be on.
Super nice. Maybe before we kind of talk about T1 and what kind of problem you're trying to solve, which actually ties in really nicely with the previous episode that we did on Ethereum recently with Tomasz and Xiaowei. Maybe let's talk about you for just a little bit. So you're here to talk about T1, but before T1 you did Enigma. Tell us about that.
Yeah, so I got into the space in 2015. At the time, I was a grad student at MIT and read the Bitcoin white paper, got really hooked into it. And even though I was in the business school, I was like, okay, let me learn as much as I can. And that was my first introduction through the Bitcoin club there. And then a friend from that circle had this research paper called Enigma. After graduation, I joined him as a co-founder in 2017. And our goal was to bring smart contract privacy to Ethereum using multi-party computation. We were looking to be like a layer 2 back in the day when these things didn't really exist. Fast forward a while, we pivoted into using trusted execution environments. At the time, there was only Intel SGX as early as 2018 because we realized in a permissionless and adversarial setting, MPC has some problems, mainly being if people collude off chain, there's no way to detect it and therefore punish people or slash people. So we worked on, with TEEs for a while. Around 2020, we pivoted our naming and our tech stack. We became a Cosmos SDK based layer 1, renamed to Secret Network. We launched private smart contracts back in September 2020. At the time, we were the only smart contracting platform on Cosmos land after Terra. We all know how that went. And yeah, we introduced primitives like privacy preserving tokens like private ERC20s, private AMMs, and really try to build a privacy first DeFi ecosystem. During my time there, which was until like late 21, I led most of the fundraising efforts, product direction, business development, and ecosystem growth efforts. And yeah, like towards the end of 21, I decided it was time to step down of that journey. Took some time off. I was quite burned out, and eventually got back into the building modes. At the time, Flashbots have made a lot of cool work with trusted execution environments and EVMs. And from my days at Secret, one of the big things for me was I wanted to be closer to the Ethereum ecosystem, and we were not. So I was very interested, um, through talking to like gurus like Andrew Miller. I was like, okay, let me look into this Flashbots things a bit more. I did a research project with them, mostly exploring the application design space with TEEs and Ethereum. And then considered building with Flashbots for a while, but then they were really focused on block building, and what I wanted to do was different, and that's kind of how T1 got started.
So Enigma, or later the Secret Network, kind of like you started off as kind of like trying to build this network on top of Ethereum and then move to Cosmos. So kind of like while there were, quite a number of projects that kind of moved that way. What precipitated that move for you guys, and why? What was it that kind of pulled you back in the end?
Well, I mean, to be quite frank, we were focusing on building a privacy platform, and in the beginning, we were trying to solve two problems. One was the privacy or private execution component, and the other one was like consensus components. Because back in 2017, like nothing came out of the box. You could just like fork Ethereum, and there were like a ton of projects that did that. But I want to say around like early 2020, Cosmos SDK or Tendermint SDK was robust enough. At the time, I'm blinking on the name. Polkadot was coming up with their own architecture, and we decided to focus on not rebuilding the whole consensus framework from scratch, which we tried, and that resulted in a lot of tech debt, and we wanted to get to market fast and build something that worked. So then we decided, like, let's just like take this thing that works and then run smart contracts inside TEs, where we could use the Cosmos SDK for the layer 1 consensus and do the computations inside TEs.
Okay, yeah, no, that makes sense. After your break, you kind of came back to Ethereum and you found things somewhat lacking. So, what problem are you looking to solve with T1 now?
When I was getting back into things, one thing that really bothered me was I had to go to centralized exchanges to trade, because when you are selling large quantities, the difference in execution is significant. So I was like, I've been building in this space since like 4, 7, 8 years now, and like I should not be trading on a centralized exchange and then withdrawing my funds back instantly, right? And thinking about like why this is a problem, I like got into the DEX realm, the DEX problems, all that stuff. And to me, the solution was we need something that is cheap and fast in terms of execution, but is not fully removed from L1 assets, which is where DeFi takes place, right? You can have cheap and fast AMMs on rollups, but because the liquidity is lacking, like, it just like doesn't make too much sense. And that was my first, let's say, hint that, it would be very cool to have a rollup that would settle instantly back on the L1, such that, like we could have this fast and cheap execution environment that is for L1 assets. That's how I started thinking about like what I should be working on or what problem I should be solving. And then quickly I realized, this is not just a DEX thing. This applies to the broader DeFi ecosystem. And like going down that rabbit hole, it also became clear to me that like, hey, okay, this is cool. However, we also have already like, tens of rollups that are out there, and the cat is out of the bag, if that makes sense. And like, why don't we have a solution that kind of like abstracts like what platform you're running on, but focuses on the application experience. Like the example I give is, if I'm taking an Uber to go from A to B, like I don't care where the Uber is running, I just care to go to my destination. And I think that's what crypto is lacking today, and that's kind of what we want to bring back.
Okay, so maybe if I kind of repackage this a little bit. So kind of if you look at the liquidity in the Ethereum ecosystem today, kind of depending on kind of like what you're looking to do, kind of you'll do it on Base or Arbitrum or elsewhere, and then kind of you might want to do something else, so you kind of need to bridge your assets kind of like from Arbitrum to Base, and or the other way around, which will take a long time, right? So kind of you have this fragmented liquidity in a way, and often kind of the solution to fragmentation is kind of having some sort of standard in terms of kind of like how does message passing work, how do you kind of how do you communicate more or less synchronously between the different rollups, right? But then kind of like when you look at standards, I mean, I'm sure you know kind of like this old engineering joke, right? So when you have 14 competing standards, someone says, let's make a universal one and unify them all, and then you have 15 standards, right? So how do you go about that?
Let me put it this way. We're taking a very pragmatic approach, and we're not in the business of creating necessarily standards. We follow what the EF, like L2 interop working groups are working on. However, one thing that's important for us is everything we build needs to be fully permissions. And what I mean by that is, like, if we look at the journey of like, solving fragmentation on Ethereum over the past 2 years, people were really excited about shared sequencing. And shared sequencing requires rollups to, participate or like, forego their centralized sequencers, therefore their sequencing revenues, and participate in this shared sequencing construct. And while that sounds excellent on paper, it did not pick off, or it didn't work, because the incentives did not align. So, all of the shared sequencing companies over the years have pivoted one by one. What we're saying is we can build an infrastructure and have this infrastructure enable cross-chain interactions, user experiences, whatever you name it, without the buy-in of a single roll-up or without the buy-in of a single application. Obviously, if these the stakeholders buy into it, it's more robust. But we are focused on, like, I am a DeFi user. I suffer from this problem on a daily basis. I'm interested in making the lives of people like me and myself better without like dealing without burning down in these like bureaucracy BD circles, if that makes sense. And I'm happy to unpack what that means.
Yes, I think you'll have to. So I'm a little confused here. So kind of if you look at T1, is this primarily a roll-up in its own right, or is it primarily kind of an interoperability solution?
So what we have is we have a rollup or like a state machine that's running inside a trusted execution environment. At first and over time, we decentralize this and make it permissionless. The idea is the TEEs provide real-time proving, and the rollup itself provides programmability. This is in a way different because a lot of companies are, let's say, doing zero knowledge proving. However, they do not focus on programmability. They just focus on proving something that happened on A to B. However, when you enhance this proving capability with actual programmability, then you unlock a lot of cool use cases and applications that just pure proving does not give you. And this way you can go towards being more of a hub rather than just like a proving network, if that makes sense.
Okay, I think you'll have to kind of give us an example here. So kind of what kind of thing can't you prove just via ZK, but can kind of address with with a TE?
Yeah, so like for example, let's just like talk through use cases and maybe that's easier. Intent bridging is huge today, right? This is the also EF's preferred solution to short-term interop across who we are in close conversations these days is using their optimistic oracle to prove or let's take a step back. Let's rewind a bit. How does intent bridging work? Let's say you want to go from an origin chain to destination chain. You lock your tokens in the origin chain. Some market maker or solver who sees that you've locked your tokens send you the funds you want to receive on the destination chain. Then there's a process of proving that this solver paid you step took place. And once this happens, then the solver can withdraw the funds that you escrowed on the origin chain, right? So there's a proving stage in the middle. There are different ways you can prove this. Like, across the most popular bridge, use their optimistic oracles. It takes 60 minutes. You can do like a multi-sig proving, which is like, really trusted. You can do a zero knowledge proving, which would take, on the order of minutes. And we can do this proving with TEs that would take like, on the order of seconds. Now, proving that the solver paid you and then therefore allowing the solver to unlock your funds is just, passing proofs. Another thing you can do while you have proving and also smart contracting capability is like this is a completely different use case that we're very interested in. And like the use case is cross-chain vaults. Like today we love earning yields via vaults in a single chain. Vaults allow us to get the highest yield for a token that we're holding, right? That's like what's why earn kind of like started back in 2020-21. Let's consider this scenario. Let's say you have USDC on Aave on Optimism. From a risk perspective, there's no difference realistically having your USDC on Aave Optimism, Arbitrum, or Base. And the yields between these rollups or Aave USDC yields between these rollups vary a lot. And no one bothers with this because the user experience of manually tracking the yields, and then when different rollup gives you higher yields, withdrawing from the original one, then going to a bridge, then bridging, then waiting for the funds to arrive, and then deposit is so painful that no one does it, right? And when we have not only proving but also programmability, what we can do is we can create logic. Let's say like an individual vault for you, which chooses which yield protocols you are okay with and which rollups you want to have exposure to, such that we can monitor in an automated way inside a T1 state machine where your funds should be based on the yield, and reshuffle your funds in a completely non-custodial and an automated way. And this requires programmability. This is not something you can do just by passing proofs.
Okay. I mean, in principle, I could set up um, a um, a vault on Ethereum mainnet that kind of looks at all of these different yield opportunities on the varying L2s and kind of withdraws and deposits automatically, right? I don't see why in principle that is I shouldn't be able to program that, right?
No, but Ethereum cannot read the yield on base or Arbitrum.
So I would kind of the thing is kind of like I would need some sort of oracle, right? And these exist, right?
Yes, you would need some sort of oracle, but also how do you like move your funds from your EOA on Ethereum to Aave on base with in an automated and non-custodial way. Like that doesn't exist.
But if you have a smart contract wallet, it could exist, right? Because you can kind of roll these transactions together.
And well, you can with a smart contract wallet allow someone to deposit your funds to the base bridge contracts, and then once your funds are on base,
Yeah, then you need another wallet to kind of handle it on that side. Okay, I think I'm beginning to understand yet. I understand now. So, kind of the tagline of T1 is that kind of like you do real time proving, right? So how much does that differ from other systems? So how long would it take on a different system to kind of do the same thing?
Sure. So I think there are some metrics on eatproofs.org on how long it takes to prove an L1 block. And I think it's currently on the order of like single-digit minutes of, I want to say 5-ish. I'm not fully sure. With the T, the proving is instant because, I mean, obviously it's a different trust assumption, right? So we're fully acknowledging that. However, as we're running the runtime inside the trusted execution environment, we can create an attestation from the TE as this, as computation is run, and prove to whatever platform that we want. This is the execution that took place instantly.
Okay, but you still need something kind of akin to a sequencer or literally a sequencer, right?
It really depends. If you want to run a smart contracting platform like we want to do, yes, we need a sequencer. And if you were like alluding to oracles, like if you just want to have an oracle network, then not necessarily. But yeah, in our case, there's a sequencer.
Okay, so can you walk me through the sequencer setup and how it works inside the TE?
So I'll start with like what's coming up short term, and then what the long term vision is. We have both me and my co-founder Orest. His background is scroll, so he knows the ZK rollup land really well. We have this, I guess, guiding principle that we want to be very pragmatic with what we're building, and we want to be solving problems that exist today. And as a result, our first stab at T1 is akin to a centralized sequencer that we have today in the market, but the centralized sequencer is running inside a trusted execution environment. What we do differently than other rollups is TEs are already like beefy node infrastructure, so we run inside our trusted execution environment full nodes of partner rollups, or what we call partner rollups. So imagine a full node of Base, a full node of Arbitrum. This allows us to read from those rollups, in addition to reading from Ethereum, aggregate their states on T1, and prove the aggregate state on L1. So that's how we're reading, let's say, the state of other rollups, or Ethereum included, in the same node infrastructure. So it's the same trust assumptions, versus having like a smart contract based oracle, if that makes sense. So that's like a V1. Basically, a user can send a transaction to T1. The T1 sequencer, like, Base or Optimism or Arbitrum sequencer, sequences these transactions, executes them, and the result can be, like T1 state updates, and we can have withdrawal requests go back to L1, or we have at least what we call proof of reads. This is basically, more like an oracle call, like saying like, hey, this like happened, this, like, let's say, market maker fill happened on Base, in going back to like this intent bridging kind of scenario, if that makes sense. And update the states. So that's how our system works. So we have, the differences, to recap, is we run our sequencer inside a TE, and we have full nodes of other rollups, and we have deposit contracts not only on Ethereum, like the current rollups do, but also on other rollups, and we can accept deposits from other rollups as well.
Okay, how do you deal with the fact that the other rollups are not necessarily finalized, right? So kind of like they are only finalized kind of like once they've been committed to L1, or kind of they've been kind of proven. So kind of like in the kind of like for an optimistic rollup, who kind of, do you guys absorb the risk, or how does this work kind of in terms of trust assumptions?
Yes. So, great question. When we look at data on, like, let's say, Arbitrum reorgs, I want to say in the last 4 years, Arbitrum reorg less than 20 times. And these reorgs are usually like 1-2 block heights, which for Arbitrum is less than 2 seconds, right? So we think, or our approach is, this is an insurance problem. Like, in real world, we have insurance against these edge cases, and there's no reason why we cannot treat these situations like an insurance on T1 as well. We can have different parameters for different rollups as to when they finalize. But yeah, like, the short answer is, yeah, we parameterize that risk based on historical reorg potential, and kind of absorb that risk to give users better UX.
Okay. Yeah, that's super interesting to hear. So kind of like if you look at the spectrum of L2s, kind of the security models vary a lot, right? So kind of it's kind of the question, kind of like, how is it architected in the first place? How do they go about data availability? How often do they commit to L1? Do they have fraud proofs? Do they even post data to L1, or are they Validium? And then you kind of have these sovereign rollups that aren't really rollups at all, but that kind of like that never kind of check in with Ethereum. So kind of do you kind of do the risk underwriting for all of these by yourself? Or if I kind of want to bridge to a rollup that you don't have, that you haven't done this for, I'm out of luck, right? So kind of say, because in principle I can set up a rollup tomorrow. How do I get integrated into T1?
Sure. So, to be very honest, like right now we're looking at base Arbitrum. We have a base full node that's running inside our node infrastructure in our, like, DevNet environment, we're adding an Arbitrum one. Our focus in the short term will be optimistic rollups and most likely OP stack plus Arbitrum.
Okay.
We are not interested in Validiums in the short term, and with the optimistic rollups, like our thinking is, as soon as the blobs go into the L1 and they're finalized, because of the current trusted sequencer assumption, or like the world we live in, we can deem things finalized. So the in-flight risk for T1 is, let's say the 2 minutes for optimism to post the blob, and then the 13 minutes for L1 to finalize. We think this is only going to get better with the 3 slots finality discussions that we have on Ethereum and all that. But we don't have we haven't looked into how to deal with Validiums now at this point. We already think that there's a big enough market just to go after actual rollups.
And you already alluded to the fact that kind of like while right now kind of you're running in a single trusted execution environment, you will increase the number of trusted execution environments in due time. And will this ever become fully permissionless? So can I run a trusted execution environment for you guys?
That's the goal. And as I mentioned, our goal is to we have identified a couple of use cases, some of these I alluded to earlier on, that make the lives of existing users and existing cross-chain applications significantly better. Our goal is to prove in a trust minimized by TEs, in a trust minimized setup, that these actually make sense and people want to use them. And only then, embark in this journey of getting things fully permissionless, because it is a lot of money, it is a lot of effort, and I think, and having been in the space for a while, I don't want to build something that is cool but no one uses, right? So, the goal is to get there, but the goal is to first prove that what we're building, has actual demand. And we also have to introduce additional, let's say, defense in depth measures as we go fully permissionless, because in the early days, either a foundation runs a TE or a set of trusted actors run the TE, and the main attack vector with TEs is physical access, and we can trust that these entities are not gonna physically break into I think when people can prove that they're running their TEs in cloud, like a Google Cloud kind of environment, it's very I would almost assume it's unrealistic to break into the TE. But when things are permissionless, this was especially a problem with the earlier generation of TEs, SGX, which you could run in your Lenovo laptop. But physical attack becomes possible. So when we make things permissionless, we have to introduce additional defense in depth measures to ensure that our system is still robust.
But then kind of you're forcing people to kind of rely on cloud infrastructure providers, and kind of we've seen them kind of revolt to people running nodes, right? So for instance, Hetzner has deplatformed everyone running nodes on the infrastructure.
Yeah, I mean, I'm not aware of that infrastructure company, and at the reality is, in the long term, we don't have to. Yet these new, let's say, generation trust execution environments are not your computers. So even if you buy the bare metals, and you run it in your own data server, it is it's not going to be the Ethereum vision of let's verify with our Raspberry Pis. So and the only reason why we have to add additional defense in depth measures is because when we make it permissionless, we don't have to limited into cloud. But in the early days, when it's like, let's say, a foundation running it, there's always some trust assumed, and that trust could be further, I guess, limited by, or like strengthened by, running things, let's say, in Google Cloud, and like, ensuring that we're not gonna have physical access to it.
Yeah. So there's a number of attack vectors here, right? So kind of like there could be the TE could be compromised, or kind of like there could be some sort of backdoor that kind of lets people access the trusted execution environment. You could also kind of run modified software, right? Instead of the software you're meant to run. Is there a way of proving that you're actually running the right software?
Yeah, I think that's called like reproducibility. And the whole idea with the TEs is, when you're setting your environment up, you attest to the bytecode that's running inside the TE, and you create a signature. That signature is what's attesting to the bytecode you're running. And every time you do a computation, you also create an ECDSA signature. And the idea is the signatures you are creating on the go as you're running new computations should be matching the initial signature that you've created and you've attested to. This process is called remote attestation, and that's how you make sure that you're running the same software in like a non-tampered way, if that makes sense.
Yeah, that makes complete sense. And then kind of the other attack vector would be kind of like the trusted execution environment itself kind of not, I mean, being broken in a way that kind of like it's no longer trusted, right? So for instance, if we were to kind of break Intel SGX, and kind of I could read kind of like the actual computation happening in there, you'd be compromised, right?
That is true. I think there's an attack vector where there are two attack vectors. One is physical access, as you're describing, and one is around access pattern leakage. That's a problem that happened with Secret Network, and as far as I'm aware, the latter is more for privacy, or like leaking private data, and then yeah. So those are like two possible attack vectors.
Okay. Do you kind of see trusted execution environments as a temporary bridge? Or do you think kind of like this will be so baked into the system that kind of you can no longer replace it with a different mode of proving?
The way I see it is, you can use whatever method you want to use. The important thing is how fast can you prove things, and what that means for the users who are, using your system or these cross-chain application, you know, um, interfaces. The reality is, we care about proving fast because it gives the superior user experience. I am not like, necessarily tied to trusted execution environments, but the reality is, we do not believe for the next 3 years there's nothing like there is, you know interest that real-time zero knowledge proving is going to be fast, but I believe otherwise, and I'm happy to get into why. That's my belief. T's are not going to be removed from the equation for another 3 years, so we lean in very heavily into them, and and when we want to strengthen T's with defense in depth, we basically go with the idea is, how can we keep things fast, and how can we make things safe. So just like one, for us, like the midterm solution is, when we make T's permissionless, we require some consensus to be reached among TE nodes. This is also what Secret did, and this would allow us to also go very fast. And in the event that there is a single TE that is misbehaving, we can attribute that misbehavior, and we could slash the stake, even if there's a single honest TE actor, right? And to us, this bake with TEs, when things become permissionless, is a more sustainable path to going, allowing real-time proving than going something with zero knowledge proving. And then in our architecture, like, there's always this like attack vector. If attacking a proof of stake system is more profitable than the stake itself,
Yeah.
you will attack it. And for us, this like the real attack vector for a network like T1 is when there are withdrawals, right? If the withdrawal amount is larger than the value at stake, it could be a single withdrawal or it could be cumulative withdrawals. Then you are at the risk of being, I guess, like rug pulled or breached, whatever you call it. So what we do, or what we want to do in the future, is we want to have this bespoke or periodic zero knowledge proof generation model where we create these zero knowledge proofs, not say every block or not say like every X time, but based on the cumulative withdrawals from the system. Let's say we have $1 billion of economic security. When we have, and 200 millions of withdrawals, we can create a zero knowledge proof, and we can verify that all those withdrawals up until that point were valid. If they're not, we can slash the system, and we can make sure whoever cheated gets their money, or is or like, let's say the amount that's stolen is recompensated to the stake. And that way, like, zero out our budget and then go again and again. And this would be a way to keep things cheap, because like zero knowledge proving, even though the cost is coming down, it's never going to be as cheap as a hardware thing, and fast and permissionless in the short run. And we think this is, like, we've seen in the market that users care about cost, right? We who have been in crypto or in the blockchain space since 2017, like, we have very high ideals, and we should strive for those ideals. And I think it's also important to realize the newcomers have a different set of priorities, and if we miss those users, then we have the risk of like missing this, like, okay, let's take this to 1 billion users narrative.
Yeah, no, I totally follow. But I also kind of got from your answer that kind of like, while you think of TEs as crucial right now, kind of like if in, say, 5 years' time you had a much faster ZK proving framework, you would be happy to kind of switch over to something less trusted, right?
Exactly. We don't
Okay.
care about, like, how we achieve something. We care about what we achieve and why achieving that is meaningful. So yeah, if in 5 years zero knowledge proving is real time, then of course, like, we have no yeah, like, I'm not married to TEs in that sense.
So, do you use one type of TE, or kind of like in principle you could make the system much more secure by using different kinds of TEE, because then kind of whenever kind of like one kind of has kind of like a 0 day or whatever, kind of like you could still fall back on the uncorrupted nodes, kind of just like we have different clients, right?
Exactly. Yes. In the short term, we will use a single TE because that allows us to go to market faster and solve user problems faster. In the long term, yes, that's something that we're looking into. And also, I think there's a misconception on this front, which I believe is important. If a lot of people talk about multi-vendor solutions as a solution to the whole thing, however, like, multi-vendor solution still requires trust on a single entity to be running the whole thing. When you do have, let's say, like, as in our future or long-term vision, when you do have different nodes, execute and form consensus, then you don't care whether it's a single vendor or multi-vendor. Because you already are verifying the computations via some sort of like re-execution. I think multi-vendor people, use that in in environments where, again, there's trust in a single party, but they're like layers of defense, and we want to remove trust from a single party first, then adding layered trust to the single party environment, if that makes sense.
Yeah, that makes sense. Maybe let's talk about one more thing, kind of like before we talk about kind of like the ecosystem and kind of like what it looks like for you guys right now. So initially, kind of like for Ethereum, the idea was that all assets would be issued on L1, and then kind of they could be acted upon kind of on rollups, but kind of in order for you as a user to kind of be able to kind of force an exit to L1, you need assets that are natively issued on L1, right? So kind of like if you have an NFT that's natively minted on Base, you have no recourse, right? So how do you see that kind of in terms of T1's security promises?
I think all assets should be issued on L1 if we want to say that they inherit the security of Ethereum. And at the same time, this is an asset issuer and user relationship and decision. I don't hold any assets that are not issued on L1, if that's kind of like makes my stance kind of like somewhat clear. And at the same time, I don't feel it's right for someone to, if there is an asset issuer on T1, I don't think it's right for us to say, no, your assets can't be issued on L1. I think they have the responsibility to communicate to their users or holders what risks that they're taking. But at the end of the day, I don't think it's our business to dictate that.
Okay. So for T1, what's live today?
So today we have a DevNet that entails a custom Rust environment runtime that's running inside TE. And then inside this TE, we also have an L1 node and a relayer. And what we're doing is we basically can deploy any applications, any EVM applications on the rollup. And we can prove the rollup state back to Sefolia. So you can imagine, you can do things like you can start from Sefolia, the L1 testnet, deposit funds to T1. You can do you can use AMMs or applications on T1, and you can exit back to or withdraw your funds back to the L1 in the next L1 block. So within we're talking on the order of seconds. You can deploy your own applications to this kind of setting. We also are using the setting to show how we can do in the intent example I just shared earlier in this podcast. We can prove faster repayments based on the ERC 7683 standard. We can prove that a solver paid a user, therefore allowed the solver to get repaid faster. This is really attractive for them because when they're getting repaid faster, they can meet the same user demand with much less capital and therefore be more profitable. The solvers that we're talking to tell us time and time again, if they are getting repaid faster, they're gonna offer better rates for the users. So we can show that. And we also have again, leveraging solvers, we can allow someone on L1 to swap against liquidity on T1 without seeing T1 exist in the background. So that's kind of what we have today. We are aiming to go to a mainnet in Q3 this year, late Q3, realistically, with a let's say a mini version of what we have today that is optimized for proving these cross-chain reads to serve this ERC7683 or intent-based bridging and cross-chain ideas. Because again, we can make this cheaper for users. We can make the system more profitable for market makers. It is, a way to make both the demand side and supply side better off. So we're building that to be ready for production. We're aiming to integrate that with existing bridge providers, to allow a better user experience. And then in Q1 of next year, we want to become this like fully permissionless rollup that you can deploy whatever app you want on mainnet. We have that today on a devnet version, but like we are taking it an intermediate step in terms of going to mainnet, and then we go for the full rollup vision.
But you're targeting other protocols and applications, right? Kind of like I, as an end user, would never interface with T1 directly.
Yes, and to be very honest, like we can build some of these use cases in-house just to the prove to the dogs will eat the dog food kind of situation. But yeah, ideal strategy for us is to make existing protocols, let's say like across, better off with real-time proving and then programmability in a phased approach.
How easy is it for protocols like across to kind of integrate T1?
What we are going to be allowing in our initial let's say mainnet that's coming out this summer or Q3 is to allow anyone to call T1 to prove a something happened on a different rollup. So in this scenario, across for example could from their origin chain get this proof of fill from T1 that shows that, hey, solver A paid your user on the destination chain and therefore allow to solver to get repaid faster. This would be basically like just a smart contract upgrade on their behalf to recognize the proof that we're already providing to their base chain. So they wouldn't need to necessarily touch T1 in any way.
Okay. Do you incentivize partnerships? So kind of like kind of in terms of interoperability, kind of like there are a number of ideas and solutions out there, and kind of it's as so often it is a coordination game, right? So kind of you need everyone in the same boat, or you need a significant number of players in the same boat. How do you get critical mass?
Yeah, I mean, our goal is the incentive is we make cheaper transactions, or we enable cheaper transactions for existing bridge users. We believe this is a significant incentive, and we have market makers and solvers in our network who are, for example, incentivized by getting repaid faster, and tell us that they would be willing to provide liquidity on a bridge that we built. Now we don't want to maintain a bridge necessarily, but if no one, if people are not convinced by faster, cheaper payments for their users, which we believe is a good enough incentive, then maybe we put it out there and see how our bridge is getting used, and see whether aggregators like the Alchemies and Third Webs of this world are willing to offer this solution because it is providing cheaper fees, and see in that direction. We're not meaningful enough to offer grants to people who are like 10 times our size. We just want to organically provide something to them.
Cool. Yeah, let's hope that works. So maybe let's kind of like zoom a little bit further out. You could argue that Solana has solved the user experience problem that you guys are tackling, at least within kind of a single ecosystem, and it's very much kind of pulling ahead in terms of user activity and at significantly lower cost than Ethereum. Why double down on Ethereum in this context?
Great question. I would argue that Solana will have the problems Ethereum is having today. We are seeing rollups on Solana or ideas of rollups on Solana. So I think this is a problem that we're going to see in the Solana land as well. Why on Ethereum? Because I believe Ethereum values of like censorship resistance and verifiability are things that resonate with us. The fact that like Ethereum is truly unstoppable is important to us, because if we're building a new open finance, this open finance platform cannot, and I don't mean to like criticize anyone necessarily, but this open finance cannot go down when we have a meme coin launch. Like Ethereum had those issues with the ICOs. That was back in 2017. The network would get congested and things would not work. But today Ethereum works, and Ethereum would work in the edge case that you mentioned. What if all the data centers deplatformed validated? Ethereum would still work. We think Ethereum captures the values and the ethos that got people like me excited back in the day, and with the Bitcoin white paper, and that's why we're building on Ethereum.
That's that's a very heartening answer. So people like you kind of have it a little bit difficult in our ecosystem, right? Because kind of people who kind of value this kind of ethos, they are typically critical of TEs and reliance on TEs. What do you think is the one thing that people in our space kind of get wrong about trusted execution environments?
I would argue it's not about trusted execution environments, but like it's a criticism to like Ethereum community um at to some extent. I don't think we have, and maybe like the new EFDX direction is an improvement, or like it's a change from this. We don't know who our users are, right? Like for years we had this narrative that, hey, L1 is not for users, L1 is for data space or like DA. And like no, like L1 should be for DeFi users. Like yes, L1 should not be for gaming users, but we need to have let's say we need to be able to differentiate between different user types, and we need to be able to know what user types that we're serving, and how. Like there was this criticism that, do EF people even use Ethereum applications? And like if they're not, that's a problem. So trusted execution environments are not perfect. We acknowledge that they're not perfect. However, today the only alternative that gives the same user experience is a trust me bro setup, which is so much riskier than trusted execution environments. Like I will give you an example. Wormhole, which is a multi-sig bridge, and I believe it was like that back in 2022, and it still is. I had to get out of Terra. I had a ton of UST, and the only way I could sell that was Uniswap by going from Terra L1 to Terra ERC20 token. It took me like 4 hours to bridge my tokens because the system is a multi-sig system, and like I don't assume ill intention, but in that 4 hours when I moved my UST from Terra to L1, like I lost, excuse my language, but a shit ton of money because the USD was free falling. And like that kind of stuff happens with multi-sigs. Like And that stuff would not happen with a TE. Like, yes, TEs are not perfect, but at least you don't have that kind of situation. So my calling is, yes, this is like not the ideal solution. And, in this world we live in, this is the only way to solve this problem. So we're pragmatic. If people don't like it, they don't have to use it. But we think it's like, it's a 100x better than what exists out there. And it's like a 100x faster than what your ideal solution is. So this is the world, this is the now we're in, and we want to serve the now.
That's a great notion to kind of end on. So where can we send people who want to kind of build with T1, on T1, using T1?
So first of all, follow us on Twitter. It's the handle is T1 protocol. And we have our DevNet portal live. Our website is t1protocol.com. And we have devnet.t1protocol.com, which is our DevNet portal. There you can deploy apps on T1. You can, bridge funds to T1, exits back from T1. We had like more than 100K non-bot users in the last month and a half since we launched the DevNet. So yeah, like, more people are welcomed. If you want to build with us, you can drop me a message on Twitter. My DMs are open. I'm not sure if we're going to share my Twitter somewhere.
Yes, we can.
But excellent.
Fantastic. Thank you so much for coming on, Can.
Thank you so much, Friederike, for having me. This was a lovely conversation.